Lesson 344 Applying Chat Templates Overview. Our view, chat templates are the secret sauce that transforms your conversational data into the exact format your model expects. This isn't a minor detail. Using the wrong template or skipping it entirely is one of the most common reasons fine-tuned models perform poorly. We're going to fix that. This lesson runs about 30 minutes and sits at an intermediate level, so expect real code, real decisions, and real consequences if you get it wrong. Learning objectives. By the end of this lesson, you'll understand what chat templates actually are and why they exist. You'll be able to apply them correctly using both Unsloth and the Transformers library. You'll know the differences between the major template families, Llama 3.1, Mistral, Gemma, and Quen, and you'll be able to test a template before you commit it to a training run. We'll also touch on building custom templates for edge cases. What is a chat template? Here's the core idea. A language model doesn't natively understand the concept of a conversation. It only sees a flat stream of text. Chat templates are what bridge that gap. They take structured message objects like this JSON with explicit roles for system, user, and assistant and serialize them into a single string that the model was trained to recognize. The JSON structure is just your working representation. The template is what converts it into something the model actually understands. This is what that conversion looks like in practice. The raw conversation becomes a precisely formatted string with special control tokens wrapping every role transition. Notice the markers. Yodes the entire sequence and bracket the role name, user or assistant, and signals the end of each turn. These aren't decoration. The model was pre-trained on millions of examples using exactly this structure, so deviating from it even slightly sends the model into territory it was never trained to navigate. Chat templates handle this entire conversion automatically, which is exactly why you need to pick the right one. Think about why this matters at a deeper level. During pre-training, the model saw its training data formatted with specific delimiters every single time. That formatting became part of how it learned to predict the next token. When you fine-tune with a different format, you're essentially teaching the model using a grammar it doesn't recognize, like tutoring someone in Spanish using French grammar rules. The content might be correct, but the structure is fighting against everything the model already knows. Consistency isn't just good practice here. It's the difference between a model that learns and one that memorizes noise. Common chat templates. The Llama 3.1 template covers models like meta-llama/llama-3.1-8 b-instruct and meta-llama/llama-3.2-3b. The Llama 3.1 format opens with WAM, then wraps every role, system, user, assistant between WAM vol and WAM vol. That end of turn token is critical. It's how the model knows one speaker has finished and another is about to begin. When you see this structure in your formatted output, that's confirmation the template applied correctly. If any of those tokens are missing or out of order, the model will misread the conversational boundaries during training. The 4 tokens you need to know for Llama 3.1 opens the conversation, role, marks who is speaking, and closes each turn. This template supports system, user, and assistant roles natively. The Mistral template covers Mistral I/Mistral 7 B instruct V0 2 and Mistral I/Mistral 8 X7 B instruct V0 1. Mistral takes a simpler approach. User turns are wrapped in and /in tags, with emps opening the sequence and per-s closing it after each assistant response. The structure is more compact than Llama's header-based system, which is why Mistral formatted text tends to be shorter for the same conversation. One important constraint: Mistral has no dedicated system prompt field. If you need to give the model behavioral instructions, they go inside the first user message. Multi-turn conversations in Mistral chain together naturally. Each user turn gets its own wrapper, followed immediately by the assistant's response and a closing spurse. The model learned during pre-training that everything between and slash is a human instruction, and everything after slash until per s is the expected response. That's the signal it uses to separate input from output during training. Mistral's special tokens starts the sequence, opens an instruction, slash instruction, closes it, and the sequence after each assistant turn. Remember, no explicit system prompt support. Embed any system-level instructions in the first user message instead. The ChatML format is used by a wide range of models, including Microsoft/Phi2, Qwen/Qwen27, Binstruct, and many community models. Here's its structure. ChatML was originally developed by OpenAI and has since been adopted broadly across the open source community. Every message, system, user, or assistant opens with role and closes with role. That symmetry makes it one of the most readable formats when you're inspecting formatted output. It also supports a wider range of roles than Llama or Mistral, including function calls, which matters if you're building tool use applications. ChatML's two tokens do all the work, opens every message, and closes it. This format natively supports system, user, assistant, and function roles, making it the most flexible of the major templates. The Gemma template covers Google/Gemma29b8 and Google/Gemma7b8. Here's how it formats conversations. Gemma's format uses @qual to open the sequence and @start_of_turn with end_of_turn to bracket each speaker's contribution. One thing to watch for: Gemma uses the label model, where other templates use ASIN. That's not a typo, it's intentional, and if you substitute ASIN here, the model won't recognize the role marker. When you inspect your formatted Gemma output, confirm you're seeing model as the response role, not as. Gemma's special tokens begins the sequence. Start_of_turn opens each turn, and end_of_turn closes it. The critical detail: Gemma uses model as the label for assistant responses. Applying chat templates in Python. Win Python, the transformers library gives you apply_chat_template directly on the tokenizer object. Here, we load the tokenizer for meta-llama/llama-3.1-8p-instruct, define a messages list. Setting tokenize false gives you back a plain string rather than token IDs, which is exactly what you want when you're inspecting the output or preparing a dataset rather than running inference. The printed result shows you the fully formatted conversation string, control tokens, and all. The output you're looking for is the complete formatted string with all the Llama 3.1 control tokens in their correct positions at the top, role headers wrapping each speaker, and closing every turn. If your output matches this structure, the tokenizer is configured correctly and your data will enter training in the format the model expects. When you use Unsloth, the process gets even cleaner. After loading your model with write single quote fast language model.fr preprint write single quote comma you call get chat template on the tokenizer. Unsloth patches the tokenizer in place. So from that point forward, calling apply_chat template on your messages uses the correct Llama 3.1 format automatically. The max_seek_length of 2048 and load _in _4-bit =true are standard settings for your P40 setup. 4-bit loading keeps memory usage manageable while you work through template validation before Unsloth supports these template names as strings. Tokens, measure, units, llama, decimal, integer part 3, fractional part 1, preserve order true for llama 3.1 and 3.2, llama 3 for llama 3.0, Mistral for Mistral and Mixtral, ShatML for the OpenAI style ShatML format, Gemma for and Qantu for Alibaba Qantu. Pick the one that matches your model family exactly. Formatting an entire dataset follows the same pattern, just wrapped in a mapping function. Load your dataset from a JSON-L file. Initialize the tokenizer for your target model. Then define a format_examples function that calls apply_chat_template on each row's method. Pass that function to write single quote dataset.map, write single quote comma, and remove the original columns to keep the output clean. The print statement at the end showing the first 200 characters of a formatted example is your sanity check. Confirm the control tokens are present and the structure looks right before you hand this data to a training loop. Testing chat templates before training. Always test your template before training. The pattern here is straightforward. Load the tokenizer. Define a representative conversation with system, user, and assistant roles. Call apply_chat_template with tokenize =false. Then programmatically check that the expected control tokens are. Don't just eyeball it. Write the assertion. If a token is missing, you'll catch it now instead of after a multi-hour training run that produces a model that can't hold a coherent conversation. Testing multiple models side by side is a smart move when you're evaluating which model to fine-tune. This loop loads the tokenizer for each model in your test list, applies the same conversation through each one's chat template, and prints the formatted result. Running the same input through Llama, Mistral, and Quen simultaneously shows you exactly how different the formatted strings look, which builds intuition for what correct output should look like for each template family. Here's what that side-by-side comparison reveals. The Llama 3.1 output is the most verbose, with explicit header tokens wrapping every role. The Mistral output is the most compact, just brackets around user turns and no system block at all. The Quen output using ChatML sits in the middle, clean and markers with explicit role labels. Same conversation, 3 completely different wire formats. This is why mixing templates across models isn't just a style issue, it's a correctness issue. One more diagnostic worth running. Inspect the tokenizer's special token inventory directly. Print the boss_token, EOS_token, and pad_token to confirm they're set to the values you expect. Then check whether your template's control tokens, things like my EOTID, or actually in the tokenizer vocabulary by converting them to IDs. If convert_tokens_to_IDs returns the unknown token ID for any of them, that token isn't in the vocabulary and the template will silently break. Catch this before training, not after. Complete example, formatting a dataset for training. This end-to-end script ties everything together. It starts with a hard-coded list of sample conversations, enough to verify the pipeline works, saves them to a JSON-L file, loads that file as a Hugging Face dataset, then initializes the tokenizer and applies the chat template across every row using a mapping function. The output confirms how many examples were loaded, prints the first formatted examples so you can inspect the structure visually, and reports the average character length across the dataset. That average length is a practical signal. If it's much longer than you expect, your conversations may be hitting sequence length limits during training. Running write single quote complete underscore template underscore example dot py write single quote from the terminal executes the full pipeline end to end. Watch the output for three things: the example count confirming your JSON loaded correctly, the formatted text block showing control tokens in the right positions, and the average character length giving you a sense of your sequence length budget. If any of those look off, the script is short enough to debug quickly before you scale up to your full dataset. Common mistakes and how to avoid them. Avoid them. The first and most common mistake: loading a dataset and passing the raw JSON structure directly to the model without applying a template. When you do this, the model sees literal JSON syntax, curly braces, quoted keys, array notation, instead of the control token structure it was trained on. The model has no idea what to do with that. The fix is always the same. Run every example through apply underscore chat underscore template before it touches the training loop. The correct pattern uses write single quote dataset.map write single quote with batched =sign true to apply your template function efficiently across the entire dataset. Setting batched =sign true lets the mapping function process multiple examples per call, which is significantly faster than row by row process. The result is a formatted underscore dataset where every entry has the proper special tokens and role structure the model expects. Mistake number 2: loading the wrong tokenizer for your model. This example loads a Mistral model but initializes the tokenizer from a Llama checkpoint. The problem is subtle but devastating. Each model family has different special tokens, different vocabulary entries for control sequences, and different template logic baked into the tokenizer config. Using a Llama tokenizer with a Mistral model means your control tokens may not exist in the model's vocabulary at all, or worse, they map to completely different meanings. The fix is one line. Always pass the model's own identifier to write single quote autotokenizer.fr om underscore preprenade. Here that's Mistral/Mistral7b instruct. No output on success is expected. A clean execution confirms the tokenizer and model vocabularies are aligned. Mistake number 3: omitting the system prompt entirely. A messages list with only user and assistant terms works syntactically. The template will format it without errors, but the model enters the conversation without any behavioral context. During fine-tuning, this means your training examples are inconsistent with how the model will be used at inference time, where a system prompt typically exists. The model learns to respond without that context, then gets confused when you add it later. The correct pattern always includes a system message as the first entry in your messages list. Here it establishes the assistant's role as a professional customer service agent. That system message isn't just documentation, it's a training signal. Every example the model sees during fine-tuning will include this context, so the model learns to condition its responses on it. The user and assistant turns that follow then demonstrate the conversational behavior you want to reinforce. Mistake number 4: using a different system prompt for every training example. If one example says be helpful, another says be friendly, and a third says be professional, the model receives contradictory signals about its own identity across the dataset. The result is a model that's uncertain how to behave, and that uncertainty shows up as inconsistent, unpredictable outputs at inference time. Define one system prompt and use it across every single training example. Something like you are a helpful, professional customer service agent, specific enough to shape behavior, consistent enough to be learned reliably. Store it as a constant in your preprocessing code so there's no chance of drift between examples. Consistency here isn't a stylistic preference. It's what allows the model to converge on a stable behavioral pattern. Mistake number 5: skipping the inspection step and going straight to training. The pattern to follow. Apply your template with right single quote dataset.map right single quote comma, then print the first formatted example and verify the expected control tokens are present before you launch a training run. 2 minutes of inspection now can save you hours of debugging a model that trained on malformed data. Make this a habit. Treat formatted output inspection as a required checkpoint, not an optional nicety. Advanced custom chat templates. Custom templates become necessary in 3 situations. You're working with a base model that has no built-in chat template. You want to define your own instruction format from scratch, or the model uses special tokens that aren't covered by any of Unslaw's built-in options. For most fine-tuning work, the built-in templates are the right choice. But it's worth knowing the escape hatch exists. Custom templates in the Transformers library use Jinja2 syntax. You define the template as a string, assign it to right single quote tokenizer.chat underscore template right single quote comma, and from that point forward apply under. This example loads a GPT-2 tokenizer which has no built-in chat template and defines a minimal structure that wraps user and assistant turns with human-readable labels. After assigning the template and calling apply underscore chat underscore template on a sample conversation, the printed output confirms your Jinja2 logic is rendering correctly before you commit it to dataset preprocessing. The formatted output from a custom template looks exactly like whatever your Jinja2 string produces. In this case, user tokens hello followed by Aston's tokens. Hi there, simple, readable, and the point isn't that this specific format is correct for any particular model, it's that you have full control over the structure when you need it. For the vast majority of use cases, use a built-in template. Custom templates are for the edge cases where no built-in option fits. For most users, stick with the built-in templates. Custom templates are an advanced escape hatch, not a default workflow. Hands-on exercise. Here's your first exercise. The goal is to apply a chat template to your own dataset end-to-end. Import load underscore dataset from the datasets library and autotoniker from Transformers. Load your custom dataset, whatever domain you're working in, recipes, customer service dialogues, technical Q&A. Initialize the tokenizer for unsloth/llama-3. Apply the chat template across the dataset. Print the first 2 formatted examples to verify the structure. Then save the formatted dataset to disk. That save step matters. You'll need this formatted data in the next lesson. Here's the complete solution. Load your JSON-L dataset and confirm the example count in the output. That number tells you immediately whether the file loaded correctly. Initialize the tokenizer from unsloth/llama-3.2-3b-instruct so the vocabulary and special tokens are aligned with the model you'll train. The apply underscore template function calls apply underscore chat underscore template on each example's messages field with tokenize =$ false, then wraps the result in a list for the batched mapper. After mapping, remove the original messages column to keep the data. The 2 printed examples are your visual confirmation. Check that appears at the top, role headers are correctly formatted and are closed as each turn, then save to a new JSON-L file. A clean save message means you're ready for training. Exercise 2. Apply 3 different templates to the same conversation and compare the outputs directly. The setup. A single messages list with a user question about machine learning and an assistant response. Your task is to run the same conversation through 3 tokenizers, llama-3.1-8b-instruct, mistral-7b-instruct-v0.2, and q. Pay attention to the structural differences. Where do control tokens appear? How are role boundaries marked? And how does character length vary across the 3 formats? This comparison builds the intuition you need to catch template mismatches at a glance. The solution loops through all three model names, initializes each tokenizer, and calls apply_chat_template with tokenize =sign false. After printing the formatted string, it also prints the total character length of the output. That length comparison is revealing. Mistral's compact format produces the shortest output, Llama's header-based format is the longest, and ChatML from QN sits in between. Same conversation, meaningfully different token counts. When you're working within sequence length constraints during training, that difference matters. The takeaway from that comparison: Mistral is the most compact, Llama is the most explicitly structured, and ChatML is the most readable at a glance. None of those is universally better. The right choice is always the one that matches your model's pre-training format. Key takeaways. White state 6 things to carry forward from this lesson. Always match the tokenizer to the model. Never mix template families. Apply templates before training, not after. The model expects its native format from the first token. Keep system prompts consistent across every training example. Inconsistency teaches the model to be inconsistent. Inspect formatted examples before launching any training run. Print them, check the tokens, confirm the structure. Use unslots get_chat_template when you can. It's the lowest friction path to correct formatting. And remember that special tokens aren't decoration, they're the structural signals that tell the model when roles change and when turns end. Quick reference: here's the canonical pattern you'll reuse in every project. Load autotoniker from transformers, initialize it with your model name, then call apply_chat_template with tokenize =false and add_generation. Wrap that in a format_fn that processes each example and returns a list required for batched mapping. Apply it with write single quote dataset.map format_fn batched =true. That's the you'll use it every time you prepare conversational data for fine-tuning. Knowledge check. Vaidyard, this Desiernos Quartzbos, you'll master these techniques quickly. Before moving on, make sure you can answer these without looking anything up. What does a chat template actually do to your data? Which template do you use for Llama, Mistral, and ChatML models? How do you call apply_chat_template in code? How do you format an entire dataset with a template? How do you verify a template is working before training starts? And how would you recognize that the wrong template was applied? What would the formatted output look like? If any of those give you pause, revisit the relevant section before continuing. Assignment. White's assignment Fiatina. Through careful analysis and practice, you'll master these techniques quickly. Your assignment is to format your actual project dataset with the correct template for the model you've chosen. Pick your model, Llama, Mistral, Quen, or another, and load its matching tokenizer. Apply the chat template to your full dataset. Then manually inspect at least 3 formatted examples and verify that the expected special tokens are present in each one. Save the result as my _project_formatted.json. Finally, document the transformation. What was the original format? Which template did you apply? And what does the final formatted structure look like? That documentation will be useful when you're debugging training behavior later. What's next? Your data is now properly formatted for your model. The final step before training is validating data quality, checking for duplicates, length outliers, malformed examples, and other issues that waste GPU time without improving the model. That's exactly what lesson 3.5 covers. Don't skip it. Bad data with a correct template still produces a bad model. Additional resources. For deeper reading, the Hugging Face chat templates documentation covers the full apply_chat_template API and Jinja 2 syntax. The Llama 3 template specification details the exact token structure from Meta. The Mistral format guide covers their instruction format and multi-turn conventions. And if you need to build a custom template, the Jinja 2 template guide is the reference for the templating language itself. This diagram shows the ChatML template structure at a glance. At the top, the system block establishes the assistant's role. You are a helpful assistant. Below that, the user turn wraps the input instruction in Cordiara and Cauldsan. The assistant block follows with the model's response. The multi-turn repeat indicator at the bottom shows that this user assistant pair can chain as many times as needed, with each turn getting its own wrapper. The structure is symmetric and predictable, which is exactly what makes it easy to validate programmatically. This comparison shows three template families side by side on the same input. The alpaca format is the oldest and most minimal, a plain instruction, input and response block with no special tokens. ChatML adds and markers with explicit row labels, plus a system message at the top. Llama 3 goes furthest, with opening the sequence and header tokens wrapping every role transition. The progression from Alpaca to Llama 3 reflects the field's evolution toward more explicit structural control. The format you choose must match your model's pre-training. There's no universally best option, only the correct one for your specific model. This multi-turn example uses a medical coding assistant to illustrate how context carries forward across turns. The system message establishes the assistant's role and domain. The first user turn asks for the ICD-10 code for type 2 diabetes. The assistant responds with E11. The second user turn asks a follow-up about diabetes with kidney complications, and the assistant provides E11.65, with the full condition name. Notice that the second response is more specific than the first. That's the model using conversational context from the prior turn. For your fine-tuning data, this means multi-turn examples are more valuable than single-turn ones when the task involves follow-up reasoning or context accumulation. This diagram shows what tokenization actually does to a ChatML formatted string. Each word, subword, or special token on the left maps to a unique integer ID on the right, becomes a specific ID, user becomes another, and so on through the entire sequence. The model never sees text, it only sees these integer sequences. Understanding this mapping matters for one practical reason. If a special token like isn't in the tokenizer's vocabulary, it won't get its own dedicated ID and the template structure silently breaks. That's why the token vocabulary check from the testing section is worth running every time you set up a new model. This diagram labels every component of a ChatML formatted conversation. System opens the system block, which contains the assistant's behavioral instructions, closes it. Then opens the user turn hello and closes that. Finally, opens the model's response, hi there, and closes the sequence. Every message, regardless of role, follows the same open content close pattern. That consistency is what makes ChatML easy to parse, easy to validate, and easy to debug when something goes wrong. This diagram labels the Llama 3 token structure in full. Basic and first sequence, then base start header ID, system, go fill NR, followed by the system content and bis. The same pattern repeats for the user turn. Header tokens wrap user, the user's message follows, and const EIT ID closes it. The assistant header opens the final block and the model generates its response from there. Every boundary in this format is explicitly marked with a dedicated token. which gives the model precise structural signals during both training and inference. This diagram shows what a well-constructed system prompt actually contains. Role definition comes first. Expert Python developer, which tells the model what persona to adopt. Capabilities follow, listing what the model should do. Write, debug, and optimize code. Constraints come next. No running code, no internet access, no sharing private information, which are just as important as the capabilities because they define the model's boundaries. Response format specifies Markdown, which shapes the structure of every output. Tone and style rounds it out. Concise, professional, friendly. A system prompt with all 5 of these components gives the model a complete behavioral specification, not just a vague role label. This reference table maps model families to their correct template names and token styles. Llama models use the decum start header ID format and are fully supported by Anslos's built-in templates. Mistral uses tags and is equally well supported. Gemma uses start_of_turn markers. Chat ML-based models like Qwen use er, and the built-in column tells you whether apply_chat_template works automatically or requires manual configuration. When you're selecting a model for fine-tuning, cross-reference this table with Anslos's supported template list to confirm you can apply the template without writing custom Ginger 2 code. This diagram maps the positional role of every special token in a complete conversation sequence. BOS, beginning of sequence, opens everything. The system content follows, separated from the user message by the first SAP token. The user content comes next, separated from the assistant's response by a second SAP token. The assistant content closes the sequence, followed by EOS, end of sequence. Each token has a specific job. BOS and EOS frame the entire input. SAP tokens mark the boundaries between speakers. If any of these are missing or misplaced, the model's ability to distinguish between roles during training degrades, which is why programmatic token validation matters. This debugging flowchart gives you a systematic path through the most common template-related training problems. If your training loss isn't converging, start here. First, check whether the tokenizer has a chat template configured at all. Second, verify the EOS token is appended after every assistant response. Without it, the model never learns where responses end. Third, confirm that instruction tokens are masked so the model only computes loss on the assistant's outputs, not the user's inputs. Fourth, make sure the template was applied to every row in the dataset, not just a subset. Work through these checks in order. Most template-related training failures trace back to one of these 4 issues, and the flowchart tells you exactly what to fix in each case.